Today I'm going to talk about the periodic table. I will try to cover certain different aspects that are related to the periodic table. Now, to get this complex idea behind this periodic table, we should be familiar with at least the first 10 elements of periodic table. And as you can see on your screen, we have this element hydrogen at the start, at the beginning, and then we have neon at the 10th position. And we know that this is the modern periodic table. We are going to discuss the modern periodic table. But if we briefly talk about the history, we have many different classification or arrangement of elements given by many different persons like the German Dobrener, and then we have this English person by the name of Newlands who gave the law of octaves, and then came the most important person, Mendeleev, who gave his periodic table in 1869. So many different classifications were given by different scientists or chemists, but they were not widely accepted because all those classifications were based on atomic mass. But then came Moseley in 1913. He gave this concept of atomic number, and now we know that our modern periodic table is based on this atomic number or proton number. And this modern periodic table has elements that are arranged in the increasing order or increasing manner of atomic number, and these digits are actually, or these numbers are actually representing the atomic number. So now if we look at the next 8 elements of periodic table, we have sodium here, magnesium here, and then this ends at argon, which has the atomic number 18. And then if we talk about the middle section of the periodic table, we know that these elements are categorized under a section called transition elements. And this part of the lecture does not focuses on the transition metals. I will try to cover this section here, and I will try to talk about this particular section, and transition metals will be covered in some future lectures. So if I specifically talk about the columns, we know that top to bottom we have these columns. So if we look at the first column, we know that this one is the first column and it starts with hydrogen. And then we have the second column which is starting from beryllium. And then we also have other columns starting from 3 to 12, and they form the transition elements section. And then comes the next thing, which is boron and carbon group. The 13 and 14 group, they are known as the boron and carbon group as they are starting from boron and carbon. And then comes the next group, which is the 15th group. And we have this column, which is starting from nitrogen. And then 16, 17, and 18. These columns are starting from oxygen, fluorine, and helium respectively. So all these numbers in chemistry terminology, in terms of chemistry, they are known as groups. So you can see that we have 18 groups in total. And then if we talk about the rows, left to right or right to left, we have these rows, and the first row is quite short because it only contains 2 elements, hydrogen and helium. And then we have second period which starts from lithium and it ends at neon. And then we have this third period which is starting from sodium and ending at argon. In total we have 7 periods, and the period number as well as the group number, they are quite important. I will talk about significance of group number and period number in the later part of this lecture. So we can judge that rows are actually termed as periods in chemistry or modern periodic table, and groups are the columns that are present here. So moving on towards the next thing, now I am trying to focus on groups one by one. I will try to talk about different groups one by one. As you can see, this first group is known as alkali metal group, or we can also call it hydrogen and alkali metal group, because we know that this hydrogen is not actually a metal. It is a non-metal, but due to some reasons, due to some peculiar or specific reason, this is placed above the alkali metals. This hydrogen is placed above the alkali metals. And now to memorize the elements that are present within this alkali metal group, we have this simple line which goes by: little nasty kids rub cats' fur. So Li here is for lithium, Na is for sodium. Now we know that K means potassium, Rb is for rubidium, and Cs means cesium. And finally we also have this last element which is Fr or francium. So this line is making our life quite easy. Now comes the next line, the next group. If we talk about second group, it also goes by the name of 2A. We know that this section here, they are the elements that belong to group B. But if we talk about this group, this is known as 1A, then we have 2A and so on. So if we talk about the second group or 2A group, we have this line for this particular group which is bearded muggers came straight back rapidly. Now Be, as you can see, Be is for beryllium, and Mg stands for magnesium, and then comes the all important calcium. Then Sr means strontium, then we have barium and radium. So all these elements form the second group, which is also known as alkaline earth metal group. So the second group is known as alkaline earth metal group. Then we come across these two groups, the 3A and 4A group. They don't really have any special name. They simply go by the name of boron group and carbon group, as they are starting from boron and carbon respectively. And to memorize all the elements that belong to the third group, we have this mnemonic, which is simple, which is quite easy. Bag it. So B is for boron, A means aluminium, G is for gallium, and then we have indium and thallium. So this baguette mnemonic is helping us memorize all the elements that belong to 3A group. Then we have this 4A group. For this we have this simple line. You can see, can simple Germans snare public? So this C represents carbon. Then we have silicon. Si is for silicon. Then we have Ge. Ge is germanium. Then we have tin. Sn represents tin. And lastly we have this Pb, which is actually lead. So the things are becoming quite easier if we memorize the elements by utilizing or using these lines. Then comes the next thing, which is the fifth A group, this one here. So you can get the idea, these groups that I am discussing right now, they are known as 4A, 5A, and so on. So next thing is quite important. We have this first element in the fifth period, which is nitrogen, and the line is quite easy. New pope assigned subordinate bishop or bishops. So N is for nitrogen, P here is for phosphorus, then we have arsenic, then we have Sb, which is antimony, and lastly we have bismuth. So all these things, all these elements form the fifth A group. And then if we move towards the 16th or 6th A group, we have this line which is Ottoman Syria sends textile to Poland. So O is the all important oxygen, then comes sulfur, then we have this selenium, then we have tellurium, then we have the last thing, which is polonium. All the elements that belong to 7A group, their names are actually rhyming, so they are quite easily memorized. But we have this line which we can utilize. We know that there is this football club by the name of Barcelona, so we can memorize by utilizing this line that FC Barcelona is in action, or FC Barcelona in action. So FCB, F is for fluorine, then we have chlorine, then we have bromine, then I is for iodine, and AT is for astenine. So you can see that all the names are rhyming: fluorine, chlorine, bromine, iodine, and astenine. And if I talk about this particular group, they are the salt formers. They are known as halogens. And in Greek, the word halo means salt, and gen means to generate, to form, to synthesize. That's why this particular group is known as halogens. And if I talk about its element, as I have already told you, that B is for bromine, I is for iodine, and AT is for astenine. And they are actually the halogens or salt formers. For instance, we have chlorine in the third period and we have sodium in the third period. They usually unite and give us the table salts that we commonly use. So that was the halogen group or the 7th A group. If I talk about 6th A group, it also goes by the name of chalcogens. Why? Because chalcos in Greek means copper, and copper is usually found in the form of ores. It is present within the earth in the form of ores. Although this group has nothing to do with the copper, Copper is present here, but this group which is known as coinage metal group, copper is present at the top of coinage metal group. But as these elements oxygen, sulfur, they are also part of ores. That's why they got this name of chalcogens. Although again I am saying this, that chalcos means copper and this group has nothing to do with the copper, but copper as well as these elements, they are present in the form of ore, they are part of ores. That's why this name was given to this particular group, the sixth A group, chalcogen. And then if we talk about this 15th group, it is also known as nectogen, although nectogen starts with P, but it's easier to memorize in a manner that nitrogen, necto, both are starting or both are sounding similar. So nitrogen group is actually known as nectogens. And these particular things are known as nectogen because they cause irritation when we inhale them, when we take in those things. They cause irritation within our breathing passageway, or more specifically within our neck region, throat region. So that's why they are known as nectogens. And then finally, we are moving towards this last group, which is the noble gas group or the inert gas group. To memorize all the elements that belong to the noble gas group, we have this line which is he never arrived. Suppose a doctor never arrived. He never arrived. That's why Karen's X-ray was ruined. So simply we can say that he never arrived. Karen's X-ray ruined. So he or He is for helium. Then Ne is for, we have this Ne which is for neon, and we have this Ar which is for argon. And then comes Kr, krypton, and then X is for xenon, and Rn is for radon. Now let's talk about these numbers. What exactly are these numbers telling us? This 7A group, this 5A group, and so on, and this 2A group. Now this group number tell us about the number of electrons, number of valence electrons that are present in the outermost shell. And we know that every element has the tendency, or every element requires at least two electrons in their outermost shell to satisfy or complete their duplet. And most of the elements stabilize themselves when they attain at least 8 electrons in their outermost shell. So this number here, the group number, tell us about the number of electron or the number of valence electrons that are present in the valence shell or the outermost shell. So if we talk about this nitrogen, as it is belonging to 5A group, that means all the elements, nitrogen, phosphorus, and so on, these elements have 5 electrons in their outermost shell, and they need 3 more electrons to attain stability, to complete or satisfy their octet. And then if we talk about this iodine, as this iodine is belonging to the 7th group, so it has 7 electrons in its outermost shell. Calcium is belonging to this second group, 2A group, so it has 2 valence electrons. And then if we specifically talk about the noble gas group, this group, xenon or krypton or argon, they have 8 electrons in their outermost shell, and they are already stable. They don't need to gain or lose electrons or share electrons because they already possess 8 electrons in their outermost shell. That's why they are known as inert gases, because they are unreactive. They don't really need to react with other things to attain stability, as they are already stable. That's why they are also called as noble gases. And they also go by the name of zero group. So quickly now we can talk about the significance of the period number. Now this period number tells us about the number of shells that any particular element possesses. As you can see, we have argon here and we have sodium here in the third period. So all these elements that belong to third period, they have 3 shells. Okay, so period number tell us about the number of shells that any particular element possesses, and this group number is for the number of valence electrons. It gives us the information regarding or related to the number of valence electrons. So that was all about the groups. Now we can move towards the next thing. We know that, like the way our housing society is divided into blocks, this particular periodic table is also divided or subdivided in the form of blocks. In our housing societies, usually blocks are formed on the basis of specific property. like the smaller area houses form block A and bigger area houses they usually form the B block and so on. Quite similarly, in the case of modern periodic table, elements are also categorized in different blocks on the basis of their specific properties. Like if I talk about this particular section, these two groups, group 1A and 2A, 1 and 2, they form the S block. We have this S block here. And then if I talk about the groups that start from 13 and end at 18, they form the P block. Elements or groups that are present within or in between S and P block, they form the D block. So we have D block, all the transition metals, all the 10 groups, T for transition, T for 10 groups. There are actually 10 groups present within this section of transition elements. They form the D block. And finally, we have to talk about this last block. We have this series. If you see closely, after 57, we have this Lathanum element which has this atomic number of 57, and after that you can see a star here. And after actinium, you can see two stars here. Now after 57, we can see that there is this an element that has the atomic number 72. So after 57, there should be 58. Now cerium has 58 atomic number. The atomic number of cerium is 58. So we can get the idea this section, this series actually fits here. And if I talk about the next series, after actinium 89, there should be thorium 90. So these two stars means that this series fits here. But due to several specific reasons, they are present in the form of F block. They are separated in the form of F block. Why? Because they don't really have similar properties like these transition metals. And if we talk about 94 plus element, they are synthetic. They are not natural. They are man-made, and due to several other reasons, these series are part of this F block and they are not part of the D block. And lastly, we can also talk about their names. As this series, the cerium series, is starting after Lathanum, that's why this series is known as Lathanite. And we know that this series is starting after actinium, that's why this particular series is known as actinide series. So that was all about this part of the video. I hope you have learned something new today. Thank you.